Let us review and master factoring skills. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll take up factoring examples, 6 of them. You need to use your skills which you've already learned to factor these. We also call them equivalent algebraic expressions since the expression is same even after factoring, correct? We are writing it in a different form. Instead of sum and difference, we are writing as a product, and that is what factoring is. You can always pause the video, answer these questions, and then look into my suggestion. We have taken variety where we have different number of terms, and all the skills which you learn will be utilized here. Let's begin with factoring skills question 1. 2x minus 1 whole square minus 8y square is to be factored. So when you look at it, you know 2 is a common factor, and therefore we can actually rewrite this question as we have 2 times x minus 1 whole square minus 8y square. So we can factor out 2. So we get x minus 1 whole square minus 4y square. So we have to factor fully, right? So now we have difference of squares. You see that, right? So as you remember, a square minus b square is basically equal to a plus b times a minus b. And therefore, we can further factor this. So we have now sum of these two terms, which is x minus 1 plus what? 4y square is 2y whole square, right? So 2y times x minus 1 minus 2y, correct? So that becomes the final factored form for us. So we have 2 times, we could rewrite this as x plus 2y minus 1 times x minus 2y minus 1. Makes sense? You see how we have factored it? Remember, 4y square is actually equal to 2y whole square, right? So therefore, we had this in this form of a square minus b square. Perfect? Now let's take up the second example, which is 6a plus b whole square minus 7a plus b minus 5. This is relatively straightforward. Let a plus b equal to, let's say, y. So in that case, the expression becomes what? It becomes 6y squared minus 7y minus 5, correct? So these two are equivalent expression. We just wrote a plus b as y. So that is another strategy. Complicated looking expressions can be simplified by simple substitution, just as we did. And now to factor this, we are looking for what? Sum and product, correct? So at this stage, we are looking for product of two numbers, let's say p and q, as 6 times 5, which is minus 30. And we're looking for the sum of two numbers to be minus 7. So the combination which will give you minus 30 and 7 is clearly minus 10 and 3. And therefore, we are going to split minus 7y and then continue with the solution, right? So let's do that. So the given expression, I could write this as, so we'll continue from here. We have 6y squared and minus 7y I'm writing as minus 10y plus 3y. And we have minus 5. So now we could take 2y common in the first two terms, which will give us 3y minus 5. We already have 3y minus 5 as the last two terms. So now 3y minus 5 is a common factor, resulting 2y plus 1. Now it is time to go back to the substitution, which was a plus b. So we'll rewrite our answer as 3 times a plus b, right, minus 5 times 2 times a plus b plus 1, correct? And that gives you the form which is we are looking for, and that is equal to, let's write here itself, 3a plus 3b minus 5 times 2a plus 2b plus 1. Makes sense? So that becomes our final answer. Is this concept clear to you? So that's another strategy. Now let's move forward and take up question number 3, which is 6x to the power of 4 minus 17x squared minus 14. Now here you could again make a substitution, x squared as equal to y. Then the whole expression will become 6x squared, rather 6y squared. I changed x to the power of 2 as y. So we write this as 6y squared minus 17y minus 14. Get the idea? So we'll again do the substitution. So this is a very powerful strategy. And now the thing is, how do we get two numbers which will give us product of 6 and 14 and the sum of minus 17? So that's kind of sometimes difficult, right? So we are looking for a product which is negative, and it's a product of 6 and 14. And we're looking for sum which should be equal to minus 17. So what could be the numbers? How do we get bigger numbers? So for that, we have a strategy right before you. So you could actually split this into prime factors, like 6 is 2 times 3 and 14 is 7 times 2. Now, combination of these numbers could actually give us the magic numbers, right? So what could it be? 7 times 3 is 21 and minus 4 will work for us, right? So we have minus 21 and 4. So we just combined two of these factors, and that helped us to get the solution faster. So you can visualize the solution. You get the whole idea, right? So that's what we are going to do. So we'll just rewrite our expression as 6y squared minus 17y minus 14 as equal to 6y squared split 17 into two terms, which are minus 21y plus 4y, right, minus 14. Now amongst the first two, we can take 3y as common. So we get 2y minus 7, and here we can take 2 common. So we get 2y minus 7 there also. Now as you can see, 2y minus 7 is a common factor, and we get 3y plus 2 as the other one. But what is y equals to? Let's rewrite y as x squared. So we get 2x squared minus 7 times 3x squared plus 2 as our solution. So reverting back to what the substitution was made is important. Many times at this stage you will find that this is also factorable. In this case it wasn't. So we'll leave it right there, okay? So let's go through the next question, which is 2x to the power of 7 minus 9x to the power of 5 minus 7x cubed. The degree is much higher. However, it's not that difficult a question. So we have 2x to the power of 7 minus 9x to the power of 5 minus 7x cubed. You see, x cubed is already common, so we could factor that out. So we have done one level of factoring. So we get 2x to the power of 4, right? Take away powers 3, right, of x. So we have 9x squared minus 7. So here again, we'll do similar factoring. We could assume x squared to be y. However, we have gone through that, so we can directly also work, right? So at times you can work directly. So now we are looking for two numbers whose product and sum is what? Well, we are looking for two numbers whose product is equal to minus 7 times 2, which is minus 14. And we're looking for the sum of minus 9. So when you add them, we should get minus 9, correct? That is what we are looking for. So what combination could give you 14? So in this particular case, as you can see, we do not have any combination, right? Because we need this minus 7 times 2. Both are prime numbers, so we could only multiply by 7 and 2, right? So we have only this combination, which is minus 7 and minus 2, right? We could do plus 2, right? Because the signs are different. You get the idea? This is minus 17. So we're looking for product of minus and some also minus. So to get 9, I should have had it, to get negative, I have to have 1 plus 1 minus, right? So it cannot be further factored. You see that? And therefore, we'll write this as x cubed times 2x to the power of 4 minus 9x squared minus 7. Note one thing with this sign, you have to take care of it. Since it is negative, we will have one positive, one negative. If we have that, we cannot get minus 9 as the sum. So it cannot be further factored. Okay, now here's the fifth question for you, which is x squared minus 8x plus 16 minus y squared. Now we have 4 terms. How do you factor this one? Well, let's try to understand this, right? So if you combine the first 3, then do you see something? Let's look at it more closely, right? So we are given x squared minus 8x plus 16, which is 4 squared, right? And we have minus y squared. You can see that the first 3 terms form a perfect square, right? So we could write this as x minus 2 x minus 4 whole square, right? And then we have here minus y square. And now we can apply the difference of square formula, which we applied earlier also. So we could write this as x minus 4 plus y times x minus 4 minus y. Make sense? Now you can open these brackets and rearrange, right? So we get x plus y minus 4 times x minus y minus 4. So that becomes the final answer. So when you have 4 terms, think about combining and then getting the solution. The last question here is having 6 terms now. If you observe these 6 terms, what do you see? Well, clearly, in this case, you could combine 2 terms each to get your solution, right? You see it very clearly how we could find the solution, right? Visualize. So let's rewrite this. We have x squared y plus x squared. These are the 2 terms. Then we have minus 7xy minus 7x. And we have plus 12y plus 12. So combining the first 2 terms, we get x squared common, and we get what? We get y plus 1. In the second terms, we get minus 7x common, and we get y plus 1, correct? And here, we can get 12 common, and we get y plus 1. So we could actually factor y plus 1 out. You get the idea. And we get x squared minus 7x plus 12. Now, x squared minus 7x plus 12, can you further factor it? Well, 12, as you know, is 4 times 3, right? So we could have product of 2 numbers, which is 4 and 3, both negative, will give you positive, right? And their sum will give us minus 7. So we could use that factoring, and we get y plus 1 times x minus 4 times x minus 3 as our solution. Do you see that? So with that, we come to an end of this beautiful series. I hope you understood all our skills were applied here to help factor these polynomials with higher degrees or with more number of terms. Perfect. So that is all about set 2. Feel free to write your comments, share your views. If you like and subscribe to my videos, be great. And in case you want to learn from me, you can always send an email on the address given. Thanks for your time and all the best.